Good day, Physics Champion. Today I'm going to divide the IGCSE Physics syllabus into main 5 parts. The idea is we're going to explain it one by one from section 1 to section 60. By the end of section 60, it means we finish the entire syllabus of IGCSE completely explanation. Then we could start past papers. Please stay in. The first unit, as usual in physics, is going to tell us many information about measurements. And to be honest with you, there is no physics without measurements. Measurements means physics. Physics presents for measurements. So in unit 1, we have measurements, quantities, and units. Let's start with the idea of quantities and units. But before we start, I just want to announce something. We will never ask you in the exams about that. But keep in mind the definition of physics is, it is a kind of science or a branch of science which seeks a cosmological phenomena. It means we're going to explain something right now here. It tells us many information about the entire universe that we are in. Let's start with the first step, measurements. And the first step, even in measurements, it could be quantities and units. Many questions, or in many questions in past papers when I corrected, I find that the students couldn't really understand the difference between quantities and units. Here is the first part of our class. When it comes to the measurements, we could say we have two main parts. Something called quantities or quantity, and unit. You could know that even under the section of quantity we have something like basic quantities and some derivable quantities. Like in basic quantities, when I say it's base quantity, they are entirely in physics 7. And to be honest with you, all physics coming out from these 7. The first one in that 7, number 1, the mass. And when it comes to mass, it's going to be measured by a measuring unit which is kilogram. The idea of the kilogram itself, it could be different from example to another. For example, we have many things, or many units we could measure the mass in. Like, mass could be measured in grams or in tons. But in sometimes in pounds, but in sometimes when it comes to the SI unit, this is what we call the international system of measurements. It's supposed to be IS, international system, but it's SI because it's mainly the council was in France, and they said Système International in French language. So that's why we said it's SI. But it means international system when it comes to English. So the mass could be measured in kilogram. This is from the quantity. The mass is quantity, but it's basic. Number 2, length. And when it comes to length, it could be measured by arm, it could be measured by centimeter, it could be measured by meter, it could be measured by kilometer. But when it comes to SI, it could be measured by only meter. Remember, the capital letter or small letter here is an issue. Like I could write it in uppercase or in lowercase, but actually it could be different depending on that. So this is in lowercase. Number 3, your time. The time also can be measured by even days or months or years. But in SI or in that kind of measuring units, I'm going to measure it in seconds. Number 4, temperature. Remember, the temperature in our temperature, whatever the temperature is, or all over the world, in many countries they are using centigrades, or what we call the degree Fahrenheit or degree Celsius. But when it comes to SI, Because we do not have any number in physics below 0 or smaller than 0. Because it doesn't make sense to have a number less than 0. Like here, I have 2 markers. When I take one, I still have 1 marker. When I take the other one, I still have 0. When I take one out of 0, it doesn't make sense in physics. So that's why we have no numbers in physics below 0. Maybe in math. But when it comes to that, I gotta say the temperature measured in Kelvin, because the smallest number in Kelvin is 0. There is no negatives. And remember, in physics, negative number, it doesn't mean that the number is below 0. No, it just means that that number is a quantity, has direction in an opposite direction. Like when I say we have 2 velocities, 3 meters per second to the right, 3 meters per second to the left. One of them could be considered positive and the other one could be considered negative. So negative in physics means in the opposite direction, but it doesn't mean that it's below 0, because there is no number below 0. It doesn't make sense for us. 5, something called the amount of matter. You know the idea of the amount of matter, you're going to study that mainly in chemistry, not in physics, and it could be measured by mole. There is an E here if you want to complete the word, but it's MOL as a symbol. Remember, that M should be in the lowercase. Number 6, current. The idea of current here means it is the amount of charge passing in a conductor during the unit of time, right? And when it comes to that, so the current, it's an international system of unit. It has an international system of unit, which is ampere. So I'm going to measure that in ampere. That was the main. Actually, we have more one quantity. It could be used here, which is as a base quantity. This is called the intensity of light. Of light. But actually we will not study that in IGCSE at all. Even in AS, even in A2, we will study that inshallah later. But it gives you the amount of energy of light, or it has some calculations. The measuring unit here is candela. 1, 2, 3, 4, 5, 6, 7 base quantities. The 7 base quantities, all physics coming out of these. I know we have many more quantities, like area, like volume, like speed, like acceleration, like volume, like energy, like power, but all this considered quantities, but it's not base, it's called derivable. Let's see what's meant by derivable. That was the first section. So the second time is derived quantities. Let's see what's meant by derived quantities. When I say derived quantity, number 1, this is just an example. Derived quantities, it means they are quantity. It could be calculated, not measured. Like the previous quantities, which were under the name of basic, we could do some measurements to find them. For example, length, I could use a meter rule to find the length. For example, mass, I could use a balance to find the mass. But when it comes to the derived quantities, we need to do some measurements. For example, if I start with number 1, but actually there is no limit. Even you can make your derived quantity and you can write your name on it. It depends, but number 1 here, it's just an example. When I say area, and to find the area, you need to know 2 dimensions, length and width. So when I say length times width, it means this is a length, and the width here, it has its own length. So length times length is going to give you a measuring unit, a quantity, which is area. So when it comes to the measuring units, here this is meter, and it was basic, or the base unit. And also here we have another base unit, and I'm going to give you meters squared. This is the derived unit. That was example number 1. In example number 2, I could say, like volume, you're going to follow the same sequence here. It's called length times width times height, or thickness. and I'm gonna give you the measuring unit for volume, which is meter cube. If I make it something higher in thinking, like when I say velocity, remember, when I say velocity or speed, I'm not talking about vector or scalar or directions right now, but when it comes to velocity itself as a concept, it is the displacement or the distance over, remember, velocity, it is the displacement divided by the time. But actually, right now, I do not care that much about the direction of the motion when it comes to velocity and speed. Later on, we will go in more details on that. But anyway, when I say distance divided by time, the distance measured in meter and the time measured in seconds. Remember that this is base quantity and this is base quantity. When I mix them together, I'm going to give you the measuring unit for the velocity, which is meter per second. In some box, you can write it meter second minus 1, because when it comes to the power of -1, it means this s presence in the denominator down. So the right answer here, it could be meter per second. This is a unit from the drift unit, but meter itself from the base and second from the base. So when I mix them up, I'm going to give you the drift unit. The third example, let's make it a little deeper, like when I say force. Any force later on in our studies, we will know that the force equal, according to the second law of Newton, its mass, the mass of the body, it's from the basic, times the acceleration. And remember that mass times acceleration, I'm going to give you the force. The mass, it has its own measuring unit. The acceleration also, it has its own measuring unit. And if we just make it more simple, so the mass, I'm going to just copy it. And later on in our studies for motion, we're going to study that in mass equal change in velocity divided by time. So it's going to be change in V divided by time. This delta means change in. So I'm going to say change in velocity divided by time. If there's no change in velocity, it means there is no acceleration and there is no entire force. So if you back to this law, and if you write the measuring unit, I could write that the measuring unit for mass is kilogram times the measuring unit for changing velocity, it's meter per second. It's the same measuring unit for velocity. This is normal. When I say 3 meters minus 1 meter gives you 2 meters also. So the change in velocity, it has a measuring unit which is meter per second, and still divided by time. So when I say divided by time, it means divided by 1 more second. So the measuring unit for the force, it's kilogram meter per second squared, and entirely we could give it a name which is Newton. So remember, this is the unit of the force, and this is the unit of the force also. So this is these two units has been given to the force. I think I need to change this. Right? So this is when it comes to the idea of the main quantity or the drift, the basic quantity. So here we have the unit of force, and this is the base unit of force, kilogram meter per second squared. But that means Newton. And so on. We have a lot of that, but in the base quantities we only have just 7. But when it comes to the drift quantities, we have unlimited number. Even, I told you, you can do your own. Like, you can do your own unit. Whatever the quantity you have times or divided or power of any other quantity, and you can discover your own unit. But remember, or your own quantity. But remember, it should has a value. Like when I say pressure, it's a force. We just said that, acting over area. So we get many benefits when we study pressure. So pressure itself as a unit, it has a value. So we need to search exactly a unit, it has a use or it has a benefit, and find out what is the unit of that. Later on in the second part in my plan, I'm going to explain something related to a second topic, which is prefixes. Prefixes, this is a system. It just makes the numbers easier for us to memorize, and it depends on something higher like that. More than that, it's called uncertainty, and we will study uncertainty later on in AS when we get the certificate of O-level. But the idea of prefixes is as the power of 10. For example, I could say, in my studies, I study, for example, the distance between the Earth and the Sun. We study that in science, and they said, it's 150 million kilometers. So if I write that in zeros, million here means 6 zeros, 2, 3, 4, 5, 6. So it's 100 million kilometers. Then I'm going to write the measuring unit over there. If I ask you to change this distance from kilometer into meter, it means I need to add more 3 zeros, 1, 2, 3. This is for K, because kilo here in prefixes means times 10 power 3. And I still have the same measuring unit, which is in SI, it's in meter. Then I still need to copy all these zeros, like 1, 2, 3, 4, 5, 6, then 150. Imagine what kind of confusion could be happen if I write all this amount of zeros. Remember, if you miss 1 zero here, it means you cancel around 9/10 of the value itself. Like if I remove 1 zero, it means you cancel a big bunch of the number. More than 90% of the number, or around 90% of the number already cancelled. So depending on that, we have another way which is considered easier. Like instead of write 100 million kilometer, I'm going to write here it's 150 times 10 power 6 for the 6 zeros and 3 zeros for kilo. So I'm going to write here times 10 power 9 meters. So this is an expression to give us what could be the distance between Earth and the Sun. I hope it's clear, because suddenly I feel another marker. There is no marker working. Probably with me right now. But anyway, so it's 150 times 10 power 9 meter. This is a perfect way to express all this number without having any mistake. If you forgot zero, if you decrease 1 zero, or if you increase 1 zero. Right? This is what's meant. And also I can change it to be, for example, 1. I can change it to be 1.5 times 10 power. Remember, I'm going to move this sign to, so again, I could write here, it's 11 meters. So this is also a right idea, or a correct idea to express the same number, but it depends. Like here I have 2 sig fig, no decimal places. Here I have 2 sig fig, and I have 1 decimal places. So it depends on the idea of writing or how you could write it. Actually, we are not that much care when it comes to the number of sig fig or the decimal places in IGCSE, but later on in AS you could need it. I hope that was helpful for you, and see you in the next class in part 2 out of 60. Bye.